GHC 2021. And I had a similar thought with enabling this by default with why can't we put a bang on the type signature? But before we get into that, so why are bang patterns good, right? What is the advantage of that? They allow us to mark an argument as being evaluated before we evaluate the function bodies, which is great for fixing space leaks in some cases, and it can massively improve performance through automatic unboxing. So here, if we have this plus function with two arguments, we can put the bangs on X and Y, and this gets translated by the compiler to essentially calls to seek in the before we evaluate the function body. And this also unlocks automatic unboxing, which again, we have the definition using seek, and the compiler internally will generate something that's called a worker, where we then pass unboxed integers to the function and back from the function, and often it allows us to avoid heap allocation. It's really great for performance, lots of upsides to that. Also interrupt me with questions at any time. So why not use unboxed types directly? So we have int hash, char hash, word hash, and it's great for performance, like I've used them in the past. They are kept in registers or are stored directly on the stack, so you don't have as much allocation pressure. You don't do as much pointer chasing, right? If you have a regular boxed int, you have to actually look at the pointer, where is the int stored, things like that. But there's horrible ergonomics, right? You don't have a num instance, you can't use them with monad. You run into issues with representation polymorphism if you try to unbox a tuple. You can use unbox tuple, but then you're at a different kind. And especially representation polymorphism, it's improving, but every time I use it, I basically run into a new GHC bug, and then I get one of my colleagues to fix it. But progress is being made there. It gets more usable with every release, I think. And you get a lot of these kinds of errors, right? You add a return statement, and you use an unbox type, and suddenly you get couldn't match lifted type with unlifted type. Then you unbox your IO new type manually, and all those things. So if you use that if you've written this kind of code, you know exactly what I'm talking about. But thankfully, it's Haskell. We don't necessarily have to choose between the performance and the convenience. So typically, with bang patterns, right, we just write our regular code using box types, and then the performance is achieved through the automatic unboxing that worker wrapper performs. And I think it's generally great when it happens, but it relies on function arguments being strict, and there's a lot of ways to do this. Bang patterns being, I think, one of the important ones. There's also seek, strict data, you can have strict fields. And I think there's some downsides to this, and especially in Haskell, you're very used to have invariants in the types. And for performance critical codes, whether or not unboxing happens or can happen is one of these invariants you actually care about. And most Haskell developers that work with performance code eventually develop an intuition. Will this code unbox? Will this code not unbox? But even then, somebody surrounds you, refactors the code surrounding your code that you wrote in another commit. Suddenly, unboxing stops working and performance is like terrible. So the first idea here is then, why not can we put the bangs on the type patterns, on the types, right? Why can't we just write the plus on the right side where we have the bangs on the ints? I don't think there's any too big of a reason. I think it's just never been proposed, similar to enabling bang patterns by default.
Clean has had it for 30 years.
See, so one more reason why we couldn't just have it. And I think that the sugaring as well is like very trivial, right? If you write a function with bang patterns, you can just generate this kind of desugaring where you then take the user's written definition of the body and you add the seeks for bindings. You extend this also for expressions. You have an expression, you give it a type signature with a bang like that. You just add a lambda with a seek. I think that also is maybe slightly more controversial, but I think that also would work well. One open question is nesting, right? Should you be able to put the bang inside a type? I think probably not the best idea in terms of simplicity. You can definitely not do it if the outer type is lazy. How would that work, right? You can't. Oops. And it's gone.
Sorry, what is the difference between the second two?
That I didn't do it right in the slides, I guess. Yeah. So the idea was In the second one is supposed to have a bang on the maybe as well, right? Like an outer bang and an inner bang, which you could do, right? But then with some types, product types, there's actually work involved in forcing those. So it's doubtful how beneficial that is. But for the outermost, I think this is uncontroversial. We should just have that. I want to work on that. I will probably work on that. But is this good enough, right? That's one question. So there is a big problem, a problem with that, which is higher order functions, right? If you have this function, I just wrote a random toy function, mapping over some mutable vector with a higher order function. You pass in a function from word to word. GHG generates code for this function. It doesn't know if this function you're going to pass in is strict, so unboxing doesn't work. Because GHG must pick the calling convention for this word-to-word function ahead of time without knowing anything about the implementation or without its strictness. So the only valid choice is that we actually pass the boxed word. So I tried this for fun yesterday. And if you like hard code the function, don't make it a higher order function, it's about 100% faster or slower, depending how you view it. And there are workarounds, and I've used both of those. So you can manually unbox your types, which gets back into terrible ergonomics. You have to write your unboxed functions. You can't use the function composition. You can't use ID. Yeah, like people have written their own unboxed preludes. I think Subin has his own unboxed prelude to work with things like that. You can force the higher order function to inline, but that can sometimes be brittle, especially with recursive functions. They don't like to be inlined. Then you have to use the magic inline function, and then it breaks because you have a constraint. And it's somewhat brittle. And even if it works, it's code bloat because you essentially specialize the function for every function you call it with, which is fine if you have two functions. But if it's some library where you expect to have a lot of different functions it's called with, it's really not ideal. And why does automatic unboxing fail us here, right? Again, the user writes our function over box types. What GHG does internally is it generates a boxed interface, the wrapper, and an unboxed body, the worker. And then it relies on the wrapper being inlined at the call side and get optimized away. And that's when we get the good performance. So this looks something like this, right? We have our boxed wrapper, unboxed worker. We inline the wrapper, and we get this sequence here of a boxing operation and unboxing operation. They cancel out. We are just left with a call, taking an unboxed argument, the x being the unboxed value here. But for higher order functions, at the call side, there is no, at the side where we call the higher order function, the wrapper, there is no unboxed thing yet because that only occurs in the body of map vector here. So inside map vector, we end up reboxing this value just to pass it to our function from word to word. And inside our actual translation function word to word, we unbox again. So at best, we get all the downsides of worker wrapper. We don't really get any benefits. GHG is smart enough to not do useless inlining like that. There's some tricks to make it not as bad, but we can't get around the reboxing currently. So what if the bang on the type, right, had more meaning like this? So this is the controversial part of the talk. I think we should definitely do the first part with bangs on the types. This part, I'm not 100% sure yet, but I want to try at least to put out together an implementation. So what if we put the bang pattern as an operator to the type level, right? So think of it as a magic type family. You apply it to some type, and it gives you back the unboxed type that's related to that, or a strict counterpart. You can do both. You need some desugaring, of course, right? But now the user can again write his nice boxed version. We use our bangs to indicate, oh, this higher order function expects to get past the function that is strict in its argument, that returns something that can be unboxed. Yes?
So just to be perfectly clear, do we mean boxed or lifted here? I mean, is it the unlifted version that bang T? Is that the unlifted version of T, or is it some because I mean, unboxing an arbitrary type could be.
Well, it has to be a concrete type, right? For unboxing to work.
Right. But if I say like bang function, for instance, right? What is the what is the unboxed type corresponding to a function type?
Oh, well, we found... All right, so the question is, what if we put the bang, for example, in front here, right? What is the unboxed version of a function type? I think for a function type, it would just be an unlifting operation, right? Where you eliminate the bottom case.
Which seems like, in general, that should be the answer, right? Is that the bang will give you the unlifted version, not the unboxed. Well, unboxing is kind of an implementation detail.
Well, no, right? Because... All right, so what Ben said is that unboxing is kind of an implementation detail. So the issue is with the higher order functions, you have to, again, generate the code ahead of time. And like if you just take it as an unlifting operation instead of an unboxing operation, you end up passing a box, right? You end up passing a pointer to the word instead of passing the unboxed word to your function.
But that's one, I mean, but that's not to say that you couldn't further unbox, but the thing you guarantee is liftedness.
Well, how could you then know that you're allowed to expect an unboxed thing? Do you have to agree on the calling convention ahead of time when you compile map vector?
Right, but I guess maybe we take this offline.
Yeah, sure. Right, and similar to what you said, right? Again, I agree that you could just do the unlifted thing, but if we know the function is strict, right? Why would we not just go one step further and say GHG is allowed to just use the expect an unboxed argument there if we know it's already strict? And then the user can rely on that. And then again, we have similar desugaring here. Now we need a desugaring for call sites because at the call site, the user will write f with two boxed arguments. You would need to desugar something like this. We have an unboxing operation that hopefully would cancel away, right? At the call site again, if you already have an unboxed value in the function body, this will cancel out. And again, if you do a binding similar to before, instead of seek, you now have a boxing operation for your body. Right. So this comes back to what Ben asked about, right? Should this be an operator that makes something strict a bang or something unboxed? And what should they be? Maybe a bang should just mean this is a strict value, right? Maybe a bang should mean it's an unboxed value. Maybe you have an operator with two bangs, it's like extra strict, which means unboxed. I haven't settled on something here. Maybe this is taking it too far, right? But yeah, this is a question to be answered still. And I mean,
I would like it to have meaning sort of not just for GHC, but to have a meaning, a semantic meaning, these things. So, I mean, I don't even know what box and unbox are supposed to do semantically. Seek, I can kind of understand it.
Yeah. Well, all right. So the statement was that it would be good if it had a meaning, a semantic meaning for people not familiar with how GHC works, and that seek is a more understandable meaning, whereas unboxing is a somewhat GHC internal optimization that's less transparent to the user potentially. That is a good point. On the other hand, we already have things like automatic, the unpack pragma, which sometimes is performance critical. So the question, there's a bit of a conflict between making it convenient to use and making it easy to understand. There's a lot of questions, so Rodrigo, I will just...
The unpacked pragma by other implementations is ignored because it's like a conference.
Yeah. Yeah, well, the whole point is right. If you make it a pragma, you could make this an operation that's ignored by other compilers as well, right? Like you can make it a type family that's the identity for all the compilers, and it would work as well. But I agree, there's some tension there.
Further to Leonard's point, the nice thing about the existing bang patterns is that the bang pattern is the semantic thing. That's part of the syntax. That's just about strictness. You can explain it purely semantically. And then there's a pragma, which is about the representation, and that's a compiler-specific thing. And that's a really nice point in the design space.
Okay, I will move a few slides forward, and then I take more questions. So, because I anticipated this to some degree. So what I proposed here initially is essentially this kind of bang type family and some desugaring, where we have an implicit unboxing at the call side, which makes it more explicit if you know what unboxing is, where this happens. I think it's somewhat a nice analog to term level bang patterns. It's not easy to implement outside of GHC, but I also put up some other options. So you could also explicitly convert from an unboxed function to a boxed function. I started implementing this as a library. I wanted to also showcase this here, but then I got sick, so maybe that's a sign this isn't a great idea. You could also be very, very explicit, right, where you have the boxing and unboxing. The user has to write them explicitly. I don't like it. I think it's very explicit. To some, that's a positive. To some, that's a negative. Yeah, of course, something I didn't put on the slides, you can also imagine that instead of bang, it would say unpack int or something like that, right? It doesn't necessarily have to be the bang itself. And then you could also have pragmas, where you say, you write your function as usual, and then you say unboxed worker. And GHC would associate this information with the pragma, with this function, and then at the call sites, you can do this unboxing. The question becomes harder, how, which I haven't treated here, is how do you at the call site communicate to the compiler that you want to call it with an unboxed worker. There's work to be done if we go to the pragma route. I personally prefer the bang patterns on the types instead of the pragmas. But I can see the argument for both. Okay, more questions.
So back to semantics. Does the bang on the type mean that GHC, is that an assertion that GHC is going to infer that argument to be strict, or is it an instruction to GHC to make the argument strict?
So the question was, is this an assertion that GHC will infer that this is strict, or is this an instruction that GHC will make it strict? And I think it's much in the same way where we have the, where was it, the beginning with the regular bang patterns. Where was it? Right, with the regular bang patterns, GHC is free to not insert the seeks if it can tell something is strict, right? If you write these bang patterns in a local binding, in a local let binding, and GHC knows you already passed something argumented there, GHC will drop those seeks. So I think that muddies the water between, is it, and it's definitely an assertion that in the end this will be evaluated once you enter the body. But whether or not GHC inserts the actual seek operation is an optimization question. Ideally, you want it to be optimized away, but if we can't guarantee it will be optimized away, then you have to insert it, yes.
Yeah, so with regards to the semantics, I just wanted to comment that there's a paper which is called Call by Unboxed Value, and it doesn't say anything about how to represent this in a surface syntax, so actually it looks very similar to Haskell, but it does say something about what the semantics of these, what the semantic difference between an unlifted and an unboxed type is, for example. And they kind of introduce these four different kinds of values, which are atomic values, atomic computations, and complex values, and complex computations. And then they describe ways of how to go between these.
So, because I have to repeat the question, right? So, so there's this paper called by Unboxed Value. I've skimmed it. I haven't read it in detail, I have to admit. And this also lies out a more formal treatment without surface syntax and how on the different semantics between an unboxed value, an unlifted value, and it does this by defining four kinds of values, if you will. Primitive values, complex values, right? Then function. What was it? Atomic commutations, and I think like sanct computations in a way. I mean, this is a good formal grounding, I think, for the GHC internal treatment. Here, I want to know by people what would you like the syntax to be, right? If you sit down to write code, where do you want to put your bangs? How many bangs do you want to put there? Do you want to write pragmas? Yeah.
Is the plugin mechanism good enough to implement this feature?
Yes, I think so. So because we have parser plugins, and I think you can parse a type signature like this and then do the desugaring in a plugin. I think that because that's what I wanted to drive with the explicit function library approach that I mentioned. I obviously, again, got sadly sick, so I didn't get to that. I think you could do that in a plugin. And I think it would be very nice to try to do this in a plugin before I unleash it on GHC itself.
So, first of all, I like this idea, we've discussed it, but if you go back to the desugaring, or I guess you could have stayed on that slide, but yeah, there was the, oh yeah, there, actually, here. So the nice thing about BangPatterns is that it kind of makes it clear that the forcing won't happen until you have both arguments, right? But if you have the bang on the types, it's not immediately clear whether the semantics mean, like on partial application, the forcing will happen on each applied argument.
Is it even true that it only happens if you have both arguments?
It is true in this case, yeah. So, because you could imagine an alternative implementation where it would like do seek x and then return a lambda that takes y.
Yeah.
Because of how GHC handles like the explicit two arguments here, it makes it clearer. But if it's only in the type where the bang is, it's not clear how it should behave. What are your thoughts?
It's a really good question that I had not anticipated.
You can write the parentheses explicitly, which are currently implicit.
I'm not sure I like this. I mean, we've heard already other languages have this feature, so I would probably look there for inspiration. Bit of a cop-out, but let's go here.
Off the back of the call by unbox value, have you seen the call by push value stuff? Has that got any inspiration for you?
I've seen it. I don't think this is the that related to BangPatterns in surface syntax again. As I remember, this was more about the unknown function calling conventions, I think. But maybe I maybe I confuse it with a different paper. Yeah, ask me later.
Let's take one final question.
Okay. We will talk later, and we will take his question.
Does this contribute to the function coloring problem at all, or is there a subtyping rule for instance, passing a strict value in when a lazy value is specified at the type signature?
Can you repeat it one more time? Sorry.
Does this contribute to the function coloring problem at all, or is there a subtyping rule that lets you pass in a strict annotated type where a lazy type is specified at the type signature?
So the question was, does this contribute to the function coloring problem, or is there a subtyping rule that allows you to let you pass a strict function where a lazy function is expected? Was the question, right? In my mind, I think with the more extensive version that includes the unboxing, I think you do not want to allow a strict function to be passed where a lazy one is expected necessarily, but you should have a primop or something to convert maybe. Okay, I think I'm out of time.